Okay, let's get the third law. Power of a power law. What we had before was, we have this raised to an exponent m, and that factor is raised to another exponent. And we said this one was going to be a raised to the m times n. In other words, if you read this, there are n factors of a to the m, or n factors of m factors of a to the n. For example, here we have x cubed raised to the squared. We have here 2 factors of x cubed. It's like that. Or 2 factors of the 3 factors of x. In both cases, this will give me a 6. So instead of saying 2 factors of x cubed, we just have to multiply the exponents here. That's a power of a power. Okay. So here, there are 2 factors of x to the 5th. If you are going to do the definition, that's x to the 5th and x to the 5th. But this law tells us that we just have to multiply 5 and 2. We will get here x to the 10th. Okay? Similarly, this will be x negative 5 times 2, or this gives me x to the negative 10. And by the definition of a negative exponent, this will be more simplified if we write it as 1 over x to the 10, provided x is not 0 there. Okay, now I'm telling you again that no matter how many terms do we have inside the parentheses here, we can always look at this as just one symbol, let's say triangle. So I can actually have this as triangle squared and then negative 3. So this will give me a triangle to the negative 6. Okay, but our triangle here is 2x minus y. So again, this will be 2x minus y to the negative 6. And similarly, that is a negative exponent, so it's not considered simplified. So I'll get here, by definition of a negative exponent, 1 over 2x minus y raised to the 6. Okay, let's have number 3. If you look at this one doesn't have the same base as this, so you cannot have the product law applied to this. But when you are met with constants like this, the rule is that you have to think of a base that can be common to both of these factors. And more often, that base would be a prime base. Okay, so if it is prime, let's see, I can have this written as 5 times 5. And actually this one is what? 5 times 5 times 5. Which means for this number now, I can write this as 5 squared raised to the negative 3 times this is 5 cubed raised to the square. And what do I have for that? From the power of a power law, this gives me 5 to the negative 6, and this is 5 to the 6. Or from the product law, this will give me minus 6 plus 6 will give me 5 to the 0. And by definition of a 0 exponent, that one is equal to 1. Okay, what did we do? We expressed this in prime form, and we were able to see that 25 can be written as 5 times 5, or that's 5 squared. What about 125? It's 5 times 5 times 5, or that's a 5 cube. And there's an exponent outside, and we applied the power of power law here. We have here, then product law here. We got minus 6 plus 6, or 5 to the 0. And by definition, that's equal to 1. Okay. Let's have the last number. Can you guess what we will have to do here? We cannot apply again the product law here because 64 and 16 don't have the same base. Like what we did in number 4, we can think of a base that can be common to both 64 and 16. I can have a 4 because 4 times 4 is 16 times 4 is 64. And I can have a 4 here. 4 times 4 is 16. So I can have a base 4. But I will opt for a base 2. So how many 2's can I have in 68? 64. 2 times 2 is 4 times 2. 8 times 2 is 16 times 2 32 times 2 is 64. That means this is 2 to the 6. Okay? And I'll get here raised to the 2 minus x. What about 16? How many 2's do I get? 2 to the 4th. And I will get here 2x minus 3. And from the power of a power law, I can now have here 6 times 2 minus x in the exponent. And this is 4 times 2x minus 3. And I will get here, multiplying this, will get me 12 minus 6x. And then this gives me 8x minus 12. And now, they have the same base. I will now add the exponents. I get here 12 minus 6x plus 8x minus 12 will give me 2 to the 2x. Okay? Notice here that had we done this using base 4, let's say 4 cubed and raised to the 2 minus x, and then this is 4 squared raised to the 2x minus 3, I should have had 6 minus 3x here, and I'll get here 4x minus 6 here, and this one cancels off, and I will get here what? 4 raised to the x. Notice that 4 raised to the x is the same as 2 to the x. Why is that so? Because 4 here can be written as 2 squared raised to the x, and I will get here 2 to the 2x. In both cases, both solutions are correct. Thank you.